All right, and we are finally into solving these systems of equations, where we're going to be graphing more than one system and finding their shared solution by graphing this time. There's two ways to do this. We have pencil and paper method, which you start at the y-intercept and then you move with your slope, rising and running, and then graphing the second point. So I have my graph or my coordinate plane. I'm starting at wherever my y-intercept is, and then I rise and run. The key is to continue doing this step, rise, run. And we have to go backwards the other way, drop, run backwards, until our points get, well, that was very ugly, until our points get to the end of the graph. And we draw a line to connect the points. Then we do the exact same thing for the second equation. We find the y-intercept, and then we rise and run and rise and run, and we go to the end of the paper again. Where they intersect is the solution to the equation. Now, as we're going over the calculator method, this is where you actually physically get your calculator and practice it. And I'll give you a couple of equations to do this with. So, you got your calculator. All right. You start by pressing the y equals button. And that's going to give you that nice little chart or list where it's like y1 and y2 and all of these things equal. So our first one that we would put in, let's use y equals negative 1/3 x minus 3. And remember that you can put fractions in by using the parentheses, the number, a division sign, and then the second number like this. Negative 1/3 x minus 3. And for our second equation, let's use negative 2x plus 2. Now, once we've entered our equations, you're going to press the graph button. And when you graph it, it'll show you a coordinate plane, and it might show the two lines in the window, but it might not. You press zoom and then zoom fit if you can't see the graphs very well. This one's going to look something like this. Now, once you have the graphs, it's not necessarily going to be obvious where the point of intersection is. So you press the second button, and then calc, intersect, enter, enter, and enter to find the XY pair. And it will tell you that the XY pair is 3, negative 4. And since you're following along on your calculator, you should have gotten the same answer. And if you didn't, there's a problem, and you should raise your hand to ask. For each of these problems, graph them by hand, and then we check them with the calculator. So this is actually the one that we just did. I start at my y-intercept, which is negative 3. And let's start with this one. And then I go negative 1/3. So drop 1 over 3. Drop 1 over 3, and I'm off my graph. And then I go up and back the other way. And I am off of my graph. Then for my second equation, I'm using a different color. You don't have to. I start at my y-intercept, which is positive 2, right here. And then I have a slope of negative 2 over 1, negative 2 over 1, negative 2 over 1. Oh, I think I found my intersection. And then up 2, back 1, and then I'm off of my graph again. Now on these nice, beautiful, very well printed coordinate planes, we were able to find that our intersection is at 1, 2, 3, drop, 1, 2, 3, 4. 3, negative 4. All right, and then for my second problem, I have a y-intercept of negative 5, 3, 4, 5, and then a slope of 3 over 2. So up 3 over 2, up 3 over 2, up 3 over 2. So it's going to look something like that. And for my second graph, I have a y-intercept of -3. And then I have the same slope, up 3 over 2, up 3 over 2. And sometimes the graphs won't intersect on the graph itself, but this one is never going to intersect. So that means I'm going to actually write that it has no solution for this graph. And the way that I know that it's never going to intersect is that it has the exact same slope, 3/2 and 3/2, but it doesn't have the same y-intercept. So that means that it's going to be starting at a different point on this graph, but rising and running at the same rate, so the slope's never going to change. So there's always going to be this empty space between them. If by contrast, you had your coordinate plane, and let's say that I had a graph that was like this, and then we had a graph that obviously didn't have the same slope, but looked like this. You don't see the intersection on that graph, but if you were to extend these out further and off the graph, eventually it would intersect. So those, even though you can't always see the solution on the graph, because you see the different slopes, you know that it's going to have a solution. Whereas here, for part B, I had slopes of 3/2 for both of them and a different y-intercept. So that gave me a graph of no solution. These are the problems for you to try on your own. If you get stuck, it's a good time to raise your hand and ask for help. And if you think you got it, then the teacher will be around in a little bit to check and make sure that your answer is correct. But for the notes, we're moving on. So now we're going to be talking about checking our solutions to these systems of equations. So a system of equation is a set of 2 or more graphs that contain 2 or more points. The solution to a system of equations is a set of values that makes all equations in a system true. And we check those solutions by substituting the x and y from the ordered pair into each equation and making sure that those y values are the same for both equations. So let's go through some examples. Here's another system of equation for you to graph. For the sake of time on the video, I'm just going to go ahead and graph it for you because this is focused on checking our answers. So if you have no idea how we got these graphs, then it's a good time to raise your hand and check with your teacher. But I got the solution to be 6, 0. So my x and y that is shared for both equations is 6 and 0. Now I'm going to substitute to check my answer. So I'm substituting in 0 for y, and I'm substituting 6 for x. And I simplify these and make sure that the left side and right side are equal. This gives me 4 minus 4, and if you're confused how I got that, 2/3 of 6 gives me 12/3, which is 4. Mentally, I found 1/3 of 6 to be 2 and multiplied it by 2, but I digress. My left equation does equal 0 equals 0, so that is a solution to this equation. On the right side, I'm going to substitute 0 and 6, or 6 and 0 again. 0 for y, 6 for x, and plus 3. Well, I know half of 6 is 3, so negative half of 6 is -3. Plus 3 equals 0, so that one checks out as well. I know that my answer must be 6, 0, because I checked it in both of my equations. My red one and my blue one, just like I did on the graph. So for number 2, when I drew my graph, I think that my solution is over 4 up 1, so my x and my y. That's what I'm going to substitute in on the right. So my y is supposed to be 1, and that's half of 4 minus 1. And I've substituted, let me see if I can highlight this, 4 in for x, and I've substituted 1 in for y. When I simplify, half of 4 is 2, and sure enough, 2 minus 1 is 1, so at least it checks out in my first equation, which is my red equation. Now I'm going to check it in the second one. I substitute 1 for y and 4 for x, and 1 equals 1. So again, it checks out in my blue equation. That means my solution is definitely, positively, we have checked it for 1.